Assalamualaikum and greeting to my lecturer Puan Jurana binti Aliman and my fellow friends. Today I would like to present about the Deep Ocean Tsunami Detection Buoy from my case study 2, which is for the subject Industrial Electronics. My name is Faizuddin Ibn Izwan. My metric number is 14EM20F 2018. So for the introduction, what is a sensor? A sensor is a device that detects and responds to some type of input from the physical environment. The specific input could be light, heat, motion, moisture, pressure, or any one of a great number of other environmental phenomena. The output is generally a signal that is converted to human readable display at the sensor location or transmit electronically over a network for reading or further processing. So, what is telemetry? Telemetry is the automatic measurement and wireless transmission of data from a remote source. In general, the telemetry works in the following way, which is the sensor at the source measure at the electrical data such as voltage or current, or a physical data such as temperature or pressure. These measurements are converted to specific electrical voltage. Multiplexer combine the voltage along with the timing data into a single data stream for transmission to a remote receiver. Upon the reception, the data stream is separated into its original component and the data is displayed and processed according to user specification. This is the Deep Ocean Tsunami Detection Buoy concept. We can refer to the pictures and we can see that the typical tsunami buoy system comprises two components, which is the pressure sensor anchored to the seafloor and the surface buoy. The sensor on the seafloor measures the change in height of water column above by measuring associated changes in the water pressure. This water column height is communicated to the surface buoy by acoustic telemetry and then relayed via satellite to the tsunami warning center. So basically the system has two modes, which is standard and event. The system generally operates in standard mode, where it routinely collects sea level information and report via satellite at relatively low frequency transmission interval. Like example, for every 50 minutes. So this helps to conserve battery life and hence extend the deployment life. The tsunami buoy is triggered into event mode when the pressure sensor first detects the faster moving seismic wave moving through the seafloor. It then commences reporting sea level information at 1 minute interval to enable rapid verification of possible existence of a tsunami. The system returns to a standard mode after 4 hours if no further seismic events are detected. So as we can see at the pictures from the recorder on seabed monitor change in pressure, it can detect tsunami as small as 1 cm. Then it links the acoustic link transmit data to remote surface buoy, and then the data relay to the satellite transmit data to ground station. So next is relationship between sensor and telemetry. Telemetry system transmit real-time sensor data from a rotating device while the system is running. The system consists of one or more rotating signal conditioner or transmitter module with power source, which is battery pack or inductive, and a stationary receiver. Rotating transmitter are available to interface with most any type of sensors including but not limited to strain gauge, thermocouple, thermistor, pressure, RTDS, and accelerometer. From a basic one-channel system to a custom system that incorporates multiple sensor and sensor type in the same shaft-mounted telemetry column. Next is the advantages of the system. So the deep water pressure basically produce low force reading because it detects as small as 3 cm. Then the next advantage is multiple sensor can detect wave propagation, and it gives good advanced warning system. Unfortunately, they also have a flaw, which is the disadvantages, which the system was expensive. It also have high maintenance and cost. It also required multiple communication link, sonar, satellite uplink, authorities notation, and constant wireless. So the conclusion is, from what we learned, we can conclude that the deep ocean tsunami detection are related to the telemetry and sensor concept. It is because the system also reliable and useful because due to the complexity and uncertainty as to the weather, an undersea earthquake has the potential to generate a tsunami. The observation of sea level is a critical factor in verifying whether a tsunami has actually been generated. The use of actual sea level observation as compared with reliance on seismic observation alone. Therefore, it helps significantly reduce the risk of false tsunami warning that being issued. That's all from me. Thank you.